projects. In this video, we are going to explain about a project titled Detecting the Flying Airplane on Satellite Images using YOLO. Satellite imagery has become indispensable across a spectrum of applications encompassing the environmental monitoring, urban planning, and disaster response. With this realm, the identification of airborne aeroplanes within satellite images takes on a central role in airspace security and the traffic coordination. In the recent years, the effectiveness of deep learning powered object detection techniques has been notable in handling the intricate tasks. This study delves into the application of various iterations of YOLO, including of V3, V5, V6, V7, V8, alongside of faster RCNN with aim of detecting and precisely locating the flying aeroplane within the satellite imagery. The project objective primarily relates to create and deploy an accurate and efficient YOLO-based model for the detection of flying aeroplanes in the satellite images. The study encompasses several distinct goals. Firstly, it involves in the compilation and preprocessing of diverse datasets, which include both the flying aeroplane images and the appropriate background images, ensuring a balanced training dataset. Subsequently, the YOLO architecture is tailored and implemented with the refinement to optimize the detection of aeroplanes effectively. The model refinement process is supported by fine-tuning using the curated dataset. The research introduced the quantitative score, which provides a robust framework to quantitatively gauge the model performance. Moreover, a comparative analysis is conducted by pitting the YOLO-based model against the other contemporary object detection methodologies, underscoring its accuracy. To validate its practicality, the model's real-time capability are assessed, ensuring its suitability for the applications requiring the instant processing, bolstering its usability in the time-sensitive scenarios. And these are the basic requirements that are needed to build this project. The software requirements are Python DEL, the version of 3.7, Anaconda the version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 53 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Here we need to import the necessary Python libraries and framework such as TensorFlow, PyTorch, OpenCV, and Node specific libraries like of YOLO V5 and faster RCNN. And the next step is exploring the dataset. Acquire a comprehensive dataset of satellite images containing of the flying airplanes. This dataset should be carefully curated to encompass the various scenarios, lightening the condition and the airplane orientation. And the next step is image processing. Reprocess the dataset images by resizing them to a consistent resolution, normalizing the pixel value, and addressing the potential noise. This ensures that the input images are ready for the further analysis. And the next step is data augmentation. Apply the data augmentation technique to augment the dataset, creating the variation of the images. Techniques like rotation, flipping, and adding the noise to help the model generalize better. And the next step is data extraction and splitting the data. Extract the relevant features from the dataset, including the airplane image and the background image. Split the data into the training, validation, and the testing set to enable the model evaluation. And the next step is processing the data based on the YOLO V5 model. Here we need to implement the YOLO models using the training data to ensure its proficient recognizing flying aeroplane. And the next one is building the model. Here the first one is V3, YOLO V3. It is a widely adopted object detection model. It divides an image into the grid and predict the bounding box and the class probability for each grid cell. Its multi-scale detection capability make it suitable for identifying the object of the varying sizes, such as airplanes and the satellite imagery. And the next one is YOLO V5. It is an evolutionary step in YOLO series known for its lightweight design and the improved performance. It offers varying sizes like the small, medium, large to cater to the different computational resources. In the context of this project, YOLO V5 enhanced the architecture can potentially yield the better detection result, enabling the more accurate identification of flying airplanes within the satellite images. And the next one is YOLO V6, V7 and V8 have been released and to be developed of different versions offer the further architectural innovations, optimization techniques and enhanced detection capability should improve and explore the advancement of the satellite to improve the aeroplane detection accuracy. And the next one is faster RCN. Region Convolutional Neural Network is a two-stage object detection model that involves region proposal network to identify the potential object location, followed by the refinement using the convolutional neural network. In this project, faster RCNN proposal-based approach might provide the robust detection of airplane by accurately localizing them within the satellite images. And the next one is of user gives the input as image. Create a user interface by using the Flask where users can input the satellite image through a web application. And the next step is the given input is pre-processed and with the trained model. Pre-process the upload image by resizing and normalizing it to the input format required by the selected model. And the next step is they segmented each object and put the bounding box. Employ the pre-trained model and to segment each detected plane using the bounding box, coordinate the provided by the model, isolate the region of the interest within the image. And the last one is final outcome is displayed. Overlay the segmented airplane bounding box onto the original image. This enhanced image depicting the detected flying airplane is presented to the user via the web interface using the Flask. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing the various files within it. The data folder containing of the images within it. The sample folder containing of images that will be used to test the performance of the model. And the static folder containing of the folders like of CSS, JavaScript, images, fonts within it. And the template folder containing of the HTML documents typically include of home, index, results, sign-in, sign-up pages within it. And the YOLO V6 and YOLO V7 folders containing of the algorithms information in it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations that to execute the code and perform the sign-in and sign-up operations and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the class framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm opening the Google Chrome, I am pasting the link and then click on the enter button. After we can see that the title of the project containing of home and sign up buttons. Click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign-in page containing of the username and password, and those details are need to be filled, and then click on the login button. Here it will redirect it to this index page containing of the choose file and upload buttons. Click on the choose file button. It will redirect you to this folder containing of various images within it. I'm selecting one image and then click on the open button and then click on the upload button. Here the result is of like this with with a bounding box where it containing of the aeroplanes of the satellite image. And in conclusion, developed YOLO-based model showcase the significant advancement in detecting the flying airplane on the satellite images. Through the rigorous experimentation and the fine-tuning, the model achieved the commendable accuracy, demonstrating its potential for practical implementation in the airspace security and the traffic management system. The utilization of the deep learning and the YOLO has proven to be the robust and efficient approach for the aerial object detection in the satellite imagery. The evaluation metric confirms the model's superiority over the traditional methods, outperforming them in the term of precision, recall, and the overall performance. And overall, this study lays the foundation to the more sophisticated and reliable object detection system and realm of the satellite imagery analysis.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.